Welcome to geometry lesson. First chapter is about preparation for geometry. In this unit, we will study basic geometry terminologies. Number 1, we have coordinate plane. Coordinate plane is just a plane that has x-axis and y-axis. Number 2, point. Point is an exact location. We have 3 points in this coordinate plane. Point is usually named by capital letter. For example, this is point A, this is point B, and this is point C. The points are zero-dimensional figures because they have no length. Number 3, line. Line is a geometrical object that is straight and infinitely long. It runs endlessly in both directions. If a line contains the point A and B, then the mathematical symbol of this line is line AB. Number 4, ray. A ray is a line that has a starting point but no end point. It goes on endlessly in one direction only. This starting point is often referred to as the origin. If the ray contains the starting point A and a different point B, then the mathematical symbol of this ray is ray AB. Number 5 is a segment. Segment is sometimes called line segment. It is a part of a line between two of its points. And these 2 points are often called endpoints. So if the segment has 2 endpoints A and B, the mathematical symbol of this segment is segment AB. Lines, rays, and segments are all one-dimensional figures. Okay? Number 6, congruent. 2 objects are congruent if they have the same dimensions and the same shape. The symbol for congruence is this. For example, we have 2 segments, segment AB and segment CD. If these 2 segments have the same length, then we say these 2 segments are congruent. So we can write segment AB is congruent to segment CD. Okay, another example. Let's say we have these 2 triangles. This is a triangle ABC, and this is a triangle DEF. Angle A is equal to angle D, angle B is equal to angle E, and let's say angle C is equal to angle F. And when we compare the sides, side AB is equal to DE. Let's say side BC is equal to EF. AC is equal to DF. If all of the angles and sides are exactly same, then we say that these 2 triangles are congruent. And we write triangle ABC is congruent to triangle DEF. Does that make sense? Number 7 is midpoint. The midpoint of segment is the point halfway between the endpoints. Because the midpoint is the same distance from both endpoints, we say it is equidistant from the endpoints. So we say midpoint is equidistant from the endpoints. And if this midpoint is, let's say this is point C, then we can say that segment AC is congruent to segment BC, right? So segment AC is congruent to segment BC. Number 8, segment bisector. Segment bisector is a line, array, or line segment that cuts another segment into two equal parts. So this segment bisector could be a line, or ray, or line segment, right? Since the length from here to here and here to here are equal, we can say that if this is point C, segment AC is congruent to segment BC, right? Number 9, collinear. If 3 or more points lie on a same line, then we say these points are collinear. So for number 9, we have 3 collinear points, A, B, C. Number 10, concurrent. Concurrent means if 3 or more lines all passes through the same point, if they all have the same intersection, then we say these lines are concurrent. So for this case, we can say we have 3 concurrent lines L, M, and N. Number 11, plane. Plane is a flat surface which extends forever. So it really has no edges. Planes are two-dimensional figures. Number 12, coplanar. We say objects are coplanar if they all lie in the same plane. In this figure, we can say 3 coplanar points A, B, C because they all lie in the same plane, right? Number 13, space. Space is the region in which all material objects are located. And we say that space is a 3-dimensional figure because it has 3 different axes. Let's say here's the x-axis, here's the y-axis, here we say z-axis. Number 14, postulate, sometimes called axiom. It is a statement that is accepted without proof. For example, a line contains at least 2 points. That's just the truth, right? If we draw a line, it contains at least 2 points, right? So that's example of a postulate. Or another example, let's say we have a triangle ABC. Any triangle has 3 angles in total. That's just a fact, right? That's a postulate. Okay. Number 15, theorem. Theorem is a result that has been proved to be true using facts that were already known. For example, the sum of 3 angles in a triangle is always equal to 180. There is a reason why, and we're going to prove it. Okay? So if that's the result that has been proved, then we say that that's theorem. Number 16, two-column proof. Two-column proof is the one of the method we use to prove something using a table with the 2 columns. The first column is used to write math statements, and the second column we write reasons for each statement. Okay? 17. Paragraph proof. Paragraph proof is a written proof in paragraph form using complete sentence. Most of the time, we will write proofs in geometry either in 2-column proofs or paragraph proofs. This is an example of a paragraph proof. Number 18. Properties of algebraic proof. Many of the rules of algebra are used to prove many theorems in geometry. Okay, we're going to look at these details of algebraic proof. Suppose x and y and z are all real numbers. If x is equal to x, then we say that that's reflexive property. If x is equal to y, then we can say y is equal to x, right? If we switch these two, we say that that's commutative property. Distributive property is x times y plus z. That is equal to x times y plus x times z, right? So this is equal to this. That's a distributive property. Number 4, if x is equal to y and y is equal to z, then we can say that x is equal to z, right? That's a transitive property. Number 5, if x is equal to y, then we can add the same number each side, right? X plus z, y plus z. They are equal to each other, right? That's addition property. Number 6, if x is equal to y, we can always subtract same number each side. So x minus z is equal to y minus z. That's a subtraction property. Number 7, if x is equal to y, we can always multiply same number each side. X times z is equal to y times z, right? That's multiplication property. If x is equal to y, we can always divide each side by the same number. X divided by z is equal to y divided by z, right? But z cannot be equal to 0. Okay, that's a division property. Number 9, if x is equal to y, then x may be replaced by y in any equation or expression. That property we call substitution property. So this is all the properties that we have to know for algebraic proof.